26, and we decided to create a proposed plan to make an Olympic stadium. So we decided to have it on the railroad site on the west side of Manhattan. And we decided to put it in between 11th and 12th Avenue and 31st and 34th Avenue. The street, sorry. And I will hand it to James to explain the existing condition.
I'm James. And we did the existing conditions of the site. So our site is located on the west side, near the Javits Center, and it's currently a holding yard for trains. Our site was 1,000 feet by 1,700 feet. We drew sections of our site, and a section is a diagram of all the elevations in the site, as if you cut down through the earth. And this is our first section, AA, looking north. As you can see, we drew 10th Avenue and 11th Avenue. 11th Avenue is built directly through the middle of the site, and the train tracks are below, and they dip at the end to go beneath 10th Avenue on the way to Penn Station.
All right, this is our second section. We draw section BB, which is looking east towards 10th Avenue. Next slide. As you can see here, 34th Street is lower than 33rd Street, and the train tracks sink down below. The reason why there's a rigid line down there, it's not because we can't draw a line, it's because the fact that trains are leveled differently. Next slide. And then we drew section CC, this includes 11th Avenue, but still looking east. For this one, we see that 34th Street actually, 33rd Street shrinks, it sinks down low, and 34th Street is higher than it now. We have the High Line there just to give you a proportion of it, and yeah, the train tracks.
And the landscape architecture group is next.
Hi, I'm Simon.
For sure.
And we're part of the landscape architecture. We decided to do the site plan and the program. For the first step that we tried to do was break it down and see our main needs, what we needed to do in order to build this stadium. First off, we decided to look at public transportation, but some of the main things that we focused on were pedestrian access and the bridge. This is focusing on the main entrance points, where people are coming from, how they interact, how it all just come together. The next important thing was the High Line access, how trucks, cars, everyone would just be able to come into the stadium and unload their supplies. Another thing that we focused on was the vertical access. This applied to how everybody went up to 11th Avenue, since the whole thing is sloping up, as setting foundation, and just how everybody came together.
Okay, so here's the High Line, and the green shows the major vertical circulation, and the green in the middle shows the focal point, and we got the relative size of the stadium and pathways from our architects. Okay, so here's our secondary plan, where we developed buildings and came up with different purposes for each building. The yellow represents the stadium. We became more detailed in our pathways. This is when we transitioned the stadium from 10th Avenue to 12th, and we became more detailed. As you can see, we developed the canal system, which also connects to the fountain. We developed flag gardens, and we changed our major entrances.
Next, we have the stadium with deeper detail and with all of the entrance points. This one describes how people get from 12th Avenue into the stadium while not being able to look at the focal points. As you see right here, we split the buildings up so they'd be able to see the fountain and the focal point from different angles. And right there will be space for retail and restaurants. And finally, the final site plan, it's just the same thing, and just with deeper detail, showing how everything comes together, the pathways are made clear, and everything is in shape.
This is our inspiration for the landscape outside of the stadium. We have our flag garden, trees, fountain, which was our major focal point and canal system. And we also have scenery such as bushes, shrubs, and benches where people can rest. So,
Next, we have architecture.
Hi, my name is Daniel. I'm from architecture. We started off with our initial concept where we had a circular stadium that had radial symmetry. We started off with 3 main arcs around the stadium, here, and this is also our concept. We knew that from 10th Avenue to 12th Avenue it was sloped, so we had to compensate for it. And we knew that to compensate for it, we had to put the actual track on the second floor. And okay, so when you walk into the stadium, you get into the first floor. You've already seen the fountain, as Landscape talked about, and you walk in. So you see this huge statue in the middle of the room. So around that statue is a whole bunch of recreational space, including tables for eating or just plain relaxing. And around there is retail. Right here, this is all retail for like restaurants, souvenirs, pretty much anything. Then when you reach the second floor, you get to your seats and you see the actual stadium, the actual track itself. The track is regulation size, and the stadium is easily accessible through one of our many elevators and stairways from here. So you reach third floor, and the third floor is where you reach the box seats. The box seats are an overhang over the actual seats, and there's also a top box where you could have a view of the actual, good view of the actual of the field and a view of the Hudson River. And the basement's made primarily for the athletes' locker rooms, which would be around here. And all the other space is for media to have interviews after the actual games and for support spaces. This is our schematic where we have all our dimensions, what we thought of. The stadium itself was 250 feet high. It was 800 feet long. And this is what the final design would be in SketchUp. And here's Anthony with transportation.
Hi, my name is Anthony. So we start off with the existing traffic conditions of our site. Now, the first thing you have to think about is the new 7-line extension. You see the 7 line on the right side? It will be heading north, then west, then south, stopping right here. That's going to be where most of the people are going to stop. Most people are probably going to take the 7 line just because it's close proximity to our stadium. And the major modes of transportation are going to be 11th Avenue, Penn Station, Port Authority, Intercity Bus Terminal, M34, and New York Waterways. 11th Avenue and 10th Avenue are going to be the major avenues since they're so close. 11th Avenue will be kept, but it will be preserved just for buses and trucks. Trucks that need to deliver everything to the stadium. 10th Avenue will be only one-way northbound as of right now. And next slide, please. These are the proposed changes. These are mode splits, which is basically how people are going to reach our stadium in terms of percentages. The striking thing here is how many people are going to come through by public transportation and by automobile. Since this is 10% of thousands and thousands of people, we have to think about how many cars are going to be in the city now. And that might cause a lot more traffic. And on top of that, more people may be on the subway, more people may be on the buses, which already boggles down how many people are already there. Another thing we will be trying to change will be the M34. Currently it stops on 34th Street or West 34th Street, and we're probably going to be changing that to 39th and 12th Avenue since that's a better way for it to travel. There will be a 1-block security perimeter, which also will increase traffic, which is another thing we'll have to keep in mind. We might be rebuilding the ferry because that helps alleviate pressure across the whole city. And for 10th Avenue, we really have to think about it because we really have to think about what we want to change with 10th Avenue because that is the major avenue. It is right in front of the stadium. That's where a lot of people are going to be dropped off. That's where many of the cars are going to be going. And since it's only one-way northbound, we might want to change it to two-way, and we might want to put traffic lights halfway through, just so people can actually drop off everybody. Now I'm up to John.
Hello, my name is John O, and part of the transportation group. This is a simulation of what traffic will be like if we had 2,000 cars that we anticipate for the Olympic event. As you can see, the crosstown routes will have most traffic backed up, and we anticipate to relieve them by getting rid of parking on these crosstown routes to add more space for travel lanes. And however, on the overall system itself, traffic is largely unaffected by additional 2,000. And
I'm sorry.
so we'll also have to work with the NYPD for security, since traffic will probably be about down by increased security measures. And in addition, we have to promote the event at the Transportation Olympics and make it more appealing for people to come in by public transportation. And this is Maitreya with the structural group.
Hi, I'm Maitreya,
I'm filling in for the absent members. My name is Keith.
and we're the structural group. We coordinated with both civil and architectural in designing the stadium.
When we first started talking about structures, we talked about the loads that we applied to our structure. We talked about gravity and lateral loads. Within gravity, we have dead loads, live loads, and snow and rain. Dead loads are anything that's attached to the structure, the structural members themselves, and anything permanently in place. Live loads consist of people, furniture, anything movable in the structure, and rain and snow is the rain and snow load on the structure. Lateral loads are earthquake and wind loads. Depends on what location you are in the area, but take that into account as well. Next slide. As we talked about our structure, we went through different parts of the building and talked about the live loads and dead loads we would have. We went through ASCE 7, which is the minimum design loads for buildings, and the IBC, which is the International Building Code, to find which live loads we would have in our building. As it turns out, most of the live loads we would use would be 100 PSF, and that is what we would use. The dead loads on our structure were the dead loads on the structure were any of the members we used: concrete, steel, the stands, bleachers, anything along those lines.
Keep in mind, this could happen on Thursday. Keep going.
Okay, so coming up with the framing plan, we had to discuss the progression of loads, going from the different floors of the building to the different beams and columns, and eventually to the foundation. And we also had to consider the different types of forces, shear being the cutting of forces, moment being the bending and torsion and twisting. And we also had some difficulty coming up with the layout of columns, because it's more of a circular structure rather than like a squarish one.
We also had to take into account the placing of different columns along the foundation and the railroads. So we decided that we needed a deep foundation to place the concrete columns, which would go all the way up to the main slab, and we'd place them in between each of the rails. And we also took into account the fact that we may need to put columns on the rails itself. So we put up a situation in which we would lease out different rails from the LIRR.
This is a cross-section of our structure. You're not seeing here is on the left side and the right side will be major trusses supporting our upper stands in the structure. We'll have an upper deck and a lower deck, and the field level will be seen here.
And right here we have a huge concrete slab above the railroad tracks to support the columns and the upper levels. And this is the end of the structure.
This is a continuation of the civil group, and I'm Jonathan. And this is the utilities section. And what this is the sewer, water, electricity, and gas. The sewer is brown, water is blue, electricity is red, and gas is green. And these are the existing lines that are all around the site that will be
building level. So when we build our buildings and the stadium, the buildings for the Olympic Stadium, we need to find ways to get these lines into the stadium and into the buildings for necessary sewage, electricity, water, and gas. This way everything will run smoothly and work properly.
Hi, I'm Zobi. This is a proposed site cross section of a typical section of a typical cross section of what we want our plan to be. First off, we have 11th Avenue, as mentioned by transportation structural. That we want that to be intact. However, we want that primarily for maintenance and deliveries that would be needed for our stadium. And on 11th Avenue, that would be reconstructed deck from that, and that would be level for maintenance. Maintenance. Sorry. Anyway, so above that, we would have a 4-inch concrete slab, and that would be the foundation for our utilities level, which would be from the stadium to that second concrete slab. And that would be dirt, and that would be elaborated by Evan. And all those utilities would go down, and then they will go to 10th Avenue, which is on a 5% slope for the fountain to 10th Avenue. That was an ADA requirement to have that specific slope. So that would be basically our utilities would circulate from there, go down there, that's our deck, and train tracks there. This is
Well, my name is Evan Rizakhan. I'm part of the utilities section of the civil engineering. So what we have here is the utility section or car section. The zoom in actually to what Zobi, sorry. Okay, so as we can see here, it's going to be the main level of where the stadium will be located, and the label, the bottom level, which is the label, is going to be on the bottom of it, and we're going to need a certain amount of space in order to put all the circuit lines. The circuit lines that will be, like Jonathan mentioned before, it was the water line, the electric line, the power line, and the gas line. Obviously, the sewage line. Sorry, I keep saying obviously. The sewage line is going to be on the bottom because all the dirt is in that line, and we don't want to interfere in any of the other circuits. The water line is going to be in the middle to avoid any of the flaws. Thank you. Next slide. Any questions, comments, or concerns?
I have a question. What do you mean by frost?
What does she mean by frost? Yes.
I know the answer, but you.
No, I know the answer, but you say I could switch it over, like.
Oh, to the person. you have to. If you're the one that said it, you're the one to ask the question.
So what I meant by frost is that usually in the winter the water gets cold, and so we want to avoid the water being cold. Obviously, it's not gonna go through the pipeline.
Well, water is under pressure and it's in a circulation system, and if you freeze that and break that pressure, you have to put water in a circular loop, or else.
Two wrong answers. Typically, you put water lines down 4 feet so that as the ground freezes, the ground doesn't freeze down 4 feet, so the water line will not freeze. That's why your water pipe in the streets are 4 feet down, so that when it gets very cold outside, the water doesn't freeze. It's a frost line. You ever dig a hole in the winter? Hard. Yeah.
I just think if you're going to mention it, you should either elaborate on it or not say it.
So if any questions come, and that's a good point. The person who talked about it in the presentation theoretically knows the most about it.